This is our second example for section 4.7 inverse trigonometric functions, day 2. So again, we want to use a right triangle to write the expression the cosecant of the cosine inverse of x over the square root of x squared plus 9 as an algebraic expression. So we want to assume x is positive and the angle corresponding to the given inverse trigonometric function is in quadrant 1. So again, I need to remember that anything that is coming out, the output for an inverse trig function is going to be our angle. And so what I'm going to do is I'm going to draw in the coordinate plane a right triangle. So I want to remember here my cosine of theta is going to be my adjacent over my hypotenuse. So that's given as x over the square root of x squared plus 9. So I'm going to draw in my triangle in the first quadrant. Remember, my theta is always going from the horizontal up or the horizontal down. So in this case, it's going from the horizontal up. And my adjacent side is going to be x, and my hypotenuse is going to be the square root of x squared plus 9. So I want to find the cosecant of theta. Right? This expression all right here is equal to theta. So cosecant is 1 over sine theta. And sine theta is opposite over hypotenuse, so the reciprocal of that is going to be hypotenuse over opposite. So now I need to find my missing side because I do need the opposite. So I'm going to call that y. So I'm going to get x squared plus y squared equals the square root of x squared plus 9 squared. So this gives me x squared plus y squared equals x squared plus 9. So then I'm going to move the x squareds to the right. So I end up with y squared equals 9. I'm going to take the square root of both sides, remembering the plus minus for the number part. So I get y equals plus or minus 3. Okay, and looking at my picture, y is moving up, so I'm going to get that y is 3. So then my my cosecant is my hypotenuse, which is x squared plus 9 over 3. So this would be my answer to this problem here. Okay, so a lot of things that we already did. We know how to build these triangles. We know how to find the missing side. We know how to use SOHCAHTOA. Okay, the new piece here is really realizing that this inverse trig function, the output of that is our theta. So pause the video now and try the you-try problem on your own. So I saw that my inverse tangent is going to be my theta. So I was able to rewrite this as tangent of theta is the square root of 2 over x. I remembered that my tangent is my opposite over my adjacent. I did not have my r yet, but I put my opposite was square root of 2, my adjacent was x. Okay, then I went through and I solved for r, which is what I called my hypotenuse. It was plus or minus, but I always remember that my hypotenuse is always positive, so I chose the positive square root of x squared plus 2. And then I used that cosine is our adjacent, which is our x, over our hypotenuse, which was x square root of x squared plus 2. You do not have to rationalize these denominators. Leaving the answer just like this is fine. Please make sure to do the corresponding work and come in with any questions that you have. Thank you.